let's solve one problem. A fan is rotating at 90 revolutions per minute. It is then switched off. It stops after 21 revolutions. Calculate the time taken by it to stop, assuming that the frictional torque is constant. Let's solve this sum. So initially, the frequency of revolution, let it be equal to N0, is equal to 90 revolution per minute, which is equal to 90 by 60 revolution per second, which is equal to 1.5 revolution per second. Here it should be RPS. By mistake, here it is written RPM. So student correct it. It is revolution per second. Now, therefore, the initial angular velocity is equal to 2 pi n0, which is equal to 2 pi. The value of n0 is 1.5. So after calculation, 1.5 2s are 3 pi radian per second. So initial angular velocity is 3 pi radian per second. Now finally the fan stops. Therefore the final angular velocity omega is equal to 0 radian per second. And here it is given, it stops after 21 revolutions. So the number of revolutions to stop is equal to 21. Now we know that the angular displacement theta means the angle traced by the radius vector. So to complete one circle, we know that the angle required is 360 degree, means it is equal to 2 pi radian. So angular displacement in one revolution is 2 pi radian. Therefore in 21 revolutions, it is equal to 21 into 2 pi is equal to 42 radian. Now to calculate the required time, let us first calculate the angular acceleration alpha. Now we know that some kinematical equations in linear motion, v square is equal to u square plus twice as. Now analogous to this, in circular motion, we have a kinematical equation omega square is equal to omega 0 square plus 2 alpha theta, where omega is angular velocity, alpha is angular acceleration, and theta is angular displacement. Now we know that the final angular velocity omega is 0 and omega 0 initial velocity is 3 pi. So let us substitute, and theta is 42 pi. Now let us substitute these values, and after substituting and solving this equation, you will get alpha is equal to 9 pi upon 84. You can solve here also it further. Now also we have alpha is equal to omega minus omega 0 upon t. So let's rearrange it to calculate the t. So you will get t is equal to omega minus omega 0 upon alpha. Now omega is equal to 0 radian. So this equation get converted into omega 0 upon alpha. Now t is equal to, now let's substitute the values. Omega 0 is 3 pi upon alpha is 9 pi upon 84. So after solving this, you will get the time 28 seconds. So time required to stop the fan is 28 seconds. So I hope you have understand this, the whole problem. So after this, I am giving you only two questions for the homework. So today's homework is question number 1. Write the difference between uniform and non-uniform circular motion. And the second question is a problem. Find the magnitude of the linear acceleration of a particle moving in a circle of radius 10 cm with uniform speed, completing the circle in 4 seconds. So try to solve this